everyone. Welcome to 11785 Introduction to Deep Neural Networks. I am Ashwarya, one of the TAs for this course, and today I will be covering up for Professor Bhiksha. This will be a very brief lecture about the logistics of the course. We will first give you some motivation about how neural networks have revolutionized many tasks and have become the thing in the tech industry right now. Later, we will go over the structure of the course. We will speak a bit about the homeworks, the quizzes, the grading scheme in the course. And finally, we'll end up with some important information that you will require in order to successfully complete the course. The fact that you've all enrolled in this course suggests that you at least know a bit about how neural networks are taking over. They've become one of the major thrust areas in various problems that involve, say, things like pattern recognition, prediction, analysis, classification, etc. And the best part being that they have established the state of the art in all these problems, and oftentimes they exceed previous benchmarks by large margins. Also, sometimes we notice that they perform better than humans, which is unprecedented. We'll just go over some of the amazing things that neural networks have been doing over the past few years. This is a headline that reads that Microsoft AI beats humans at speech recognition. Speech recognition was considered quite a complicated task before the advent of neural networks. It was quite difficult in order to convert speech to, say, another format like text, because different people had different accents, different pronunciations. And with the advent of neural networks, the quality of speech recognition bettered significantly. This is just a few years ago, and if we walk 2-3 years down the lane, we notice that nowadays a lot of companies have automatic speech recognition systems that are powered by neural networks. Another very popular application of neural networks is that of machine translation. If you have followed with the news, you would know that the quality of Google Translate became immensely better overnight because they switched to using neural networks. Before using neural networks, if you were to, say, pass an English sentence, convert that to Spanish, and take this Spanish sentence and convert it back to English, you would get two different sentences, which suggests that the quality of machine translation was not very commendable before the advent of neural networks. But after this, the Google Translate performance bettered significantly. Another very interesting application is that of image segmentation and recognition. This is an image that is picked off the internet, and it contains an everyday scene with some buildings, people, and some objects that the people are carrying. You can see that neural networks have not only been able to identify these objects but also label them correctly. You can see that it's also being able to pick up small things like the bags, the cycles, and also the bigger parts of the scenery like buildings and people, etc., which is quite exciting. Another very important application of neural networks is image recognition while in motion. This is a screenshot of a video that has been picked up from this website called sitehound.com. I'd recommend going and looking up this website. It's pretty interesting. So in this application, you can see that there are some cars that are in motion, and the neural network is able to identify not only the cars as separate objects but also the car brands. You can see Nissan, Honda, Chevrolet, and all of that being identified by the neural network. This is even more difficult than identifying an image that is stationary, because these cars are in motion and the neural network has a significantly lesser amount of time in order to identify these vehicles. This can be used for various real-time applications. Another very important application of neural networks is its breakthrough in performing well during games. So games are generally considered as standard tests for AI because you generally require some intellectual thinking in order to perform well in games. Before, the standard tests for computers was to sort of see how they perform in chess or a game like that, but we've been able to perform better in chess a few decades ago, and now the focus was on more complicated games like Go. So, Go is generally considered as a benchmark for computer intelligence. And back in 2015, AlphaGo, which was a neural network that was introduced by Google, beat the 18 times world champion of Go, Lee Sedol. And this was basically a challenge that was called the Google DeepMind Challenge. And AI was able to beat a world champion at this game, which is pretty thrilling and exciting. Another application, which is my personal favorite, is how neural networks are able to caption images given to them. If you look at the first image here, the neural network is able to identify various parts of the image, although the image is not very well defined. It says man in black shirt is playing guitar. It is able to identify the man, it is able to identify the object in his hand, and also specifies the color of his t-shirt, which is a very descriptive caption. So this is one of the most interesting things according to me. And another thing that came up just a few months ago is how GANs were able to perform exceedingly well with generating human faces of people that did not exist. You should definitely go and look up this website called thispersondoesnotexist.com, where adversarial training is used in order to generate faces of people that do not exist. And I also read up recently that not just faces but entire bodies of models were being generated by adversarial networks. If you look up these people in the picture, it's very difficult to identify that they are being generated by a system. Uh, so to sum up, there has been a tremendous progress with neural networks in different fields, from art to astronomy to healthcare, and neural nets are being used even to predict stock markets these days, which says there is immense potential in this field. And also looking at it from the perspective of the job market, it has become quite an important skill to possess. And it is also considered very worthy, and having interned at I mean, having interned in the Bay Area this summer, I would definitely recommend a lot of people to learn deep learning, because it's one of the most valued skills out there, and it would definitely help you. Stand a class apart from the others who are looking for jobs, because this is still a very prominent field right now. It is still growing, and there is an immense potential in deep learning and the things that neural networks can do. The objectives of this course are to get you onboarded with neural networks, to try and make you understand how neural networks work, and also comprehending the models that do the previously mentioned tasks that we spoke about in the past few slides, and also build a few of them. You will be building networks that perform these tasks from the scratch. And we also want to make sure that you gain familiarity with some of the terminology that's used, the kind of lingo that's used in deep learning. And if you are interested, you should definitely go and look up this website, which is www.datasciencecentral.com/profile/blog/concise visual summary of deep learning architectures. You will get a whale of information from this website. We also want you to fearlessly design, build, and train neural networks for various aforementioned tasks and various other tasks that might be of your interest. And we want to caution you that this is not the course that will make you the greatest deep learning scientist of all times. No, this is just one course to get you started and to make sure that you understand terminology and state of the art architectures that are to come in the near future. You will definitely not become an expert, but this will give you amazing foundation in order to pick up a field of your interest and start working and implementing deep learning architectures for that particular field. So, at a very broad level, these are the concepts that we will be covering. We will give you a conceptual foundation as well as practical one. In terms of concepts, we'll first go over some historical perspective about how neural networks came up, what kind of intuitions led to the development of neural networks. Then we will also explain the type of neural networks and the underlying ideas behind them. And you will also need to understand the learning paradigm in neural networks, which is quite similar to traditional machine learning, but also different in its very own ways. You will understand the training, the kinds of training we do, the concepts behind it, the practical issues that you might bump into while training neural networks, and how to deal with them. We will, throughout the course, we'll also go through a lot of different architectures and their applications. There are times when you would probably have to look up papers and implement these architectures. The course is all about maintaining a balance between implementation and theory. We won't go too deep into the math, so we will try to strike a balance between the squiggles and the concepts. We want you to get a very good idea of what the concept is than just the squiggle. So we will try to balance that out throughout the course. And in terms of the practical knowledge that you will gain, you will have a very good familiarity with training. You will implement various neural network architectures during the course of the assignments that you will be asked to complete for the homeworks that you will be having. Then you will also implement state-of-the-art solutions for some problems. You will have to read up papers and also implement these architectures in order to pass the grade cutoffs. So the overall target that we have is to make sure that you are all set for further research or work in your area of interest, and you have all the background that you need in terms of deep learning in order to start off and work on your own. So the topics that we will be covering in detail are some basic network formalisms. We will start off with multi-layer perceptrons, MLPs. Then we will go on explaining about convolutional neural networks. Then we will speak about recurrent networks, Boltzmann machines. We will also touch upon some advanced formalisms like generative models, variational autoencoders, adversarial models like GANs. We will also talk about self-attention paradigms and transformer networks. We will also touch upon some applications in different fields like computer vision, where we talk about how image recognition is done. In text processing, we will talk about how modeling and generating language happens. We will machine translation, where we use the sequence-to-sequence modeling paradigm. We will also touch upon modeling distributions and generating data, reinforcement learning in games, and speech recognition too. In fact, your last assignment will be to convert speech to text, which is my personal favorite and is extremely challenging and interesting. In terms of the reading for this course, we have a list of books that is put up on the course webpage. We will not be following any particular book. We want to make sure that you get a flavor of almost everything, or all the basic information that is required for deep learning. We will not follow any particular book and go too deep into it. We will probably pick up different things from different books, and we will also ask you to refer them as and when required. And if you look at the course website, you will see that there are additional reading materials referred alongside each lecture, which you can refer in order to gain more knowledge about the topics being covered in class. You should all know by this time that the instructor is Professor Bhiksha. This is his email ID and phone number. And we have about 15 TAs from the Pittsburgh campus, Kigali, and Silicon Valley campus. You can find our email IDs on the course webpage. If you run into any issues during the assignments or during the quizzes or any other logistic issues that you might come across, please approach your local TA first, post on Piazza, and when you don't get a response, that is when you have to reach out for the other TAs. We will be conducting office hours regularly, and you can find details on the webpage. It will be up very soon. When I recorded this lecture, it was not still up, but it should be up very soon. We have office hours almost every day, so that you will receive help as and when required. Also, keep an eye on the course webpage, which is deeplearning.cs.cmu.edu. Any updates that might that we have to that we inform will be up on this course webpage. We will also make posts on Piazza that you can look up. And a very important thing that you must keep in mind is to ask us. Do not assume things. We have been there, done that. We know the kind of problems that you might run into and the solutions for them as well. Please follow this procedure as in when you run into a terrible bug or a logistic issue or something's wrong with your quiz and you don't know how to set it right. Please ask on Piazza. And if you have issues that require more time, that require more attention, please attend the office hours. The TAs are always ready to help you. And when you are attending lectures, either offline or online, please make sure that you clear your doubts on spot, because most of the quizzes are dependent on the lecture content, and you will require an in-depth knowledge of the content covered in the lecture in order to perform well in the quizzes. And make sure that you attend all the recitations, because the recitations give you a hands-on knowledge about the kind of things that you must do in your assignment. In my personal opinion, the recitations have been extremely useful because they get you started with the assignment. Sometimes assignments can be quite intense. The lectures we will have in class as well as online sections, which include the online sections in both Kigali and Silicon Valley. All the lectures will be streamed live. You could watch it while the lecture is happening in Pittsburgh, and the recordings will also be posted after every lecture on media services. And you can find the links to the recordings on the course webpage, and we will also post the live streaming link on Piazza for you to watch. It is very, very, very important that you view these lectures. In my personal experience, watching these lectures and understanding every bit of information that has been provided in the lectures is very crucial to your performance in the quizzes. Questions can come up from different parts of the lecture. We will talk about the quizzes in more detail. And even if you think you know the topic, please watch the lectures. You will be surprised to know there is so much more information and depth to the content. And like I already mentioned, your marks will totally depend on viewing these lectures and understanding every small bit of information that has been provided in these lectures. The schedule of the lectures has been posted on the course website. You should be cautioned that the schedule for the later half of the semester might vary a little bit. It might get a little fuzzy because we have guest lecturers coming in the later half of the semester, and that is when things can get a little fuzzy. However, you will be informed about any change that will happen on the course website as well as Piazza. So you will be informed well in advance in order to prepare for these lectures. We have guest lectures by a number of distinguished faculty in the Pittsburgh campus, and we also have a few other professors in mind, and you will be informed about this as early as possible. So about the recitations, we will have 13 recitations, and these recitations will cover implementation details and basic exercises. Whenever you have an assignment that is yet to be released, we will be covering content about how to get started with the assignment, and some implementation details will be given out. And whenever you don't have an assignment, we will be taking a more general approach and trying to cover up implementations of other interesting applications. And it is very important that you attend the recitations because, like I said before, they will get you started with the assignment and provide some direction in order for you to perform well. The topic list is provided on the course website. You should definitely go look it up. And once we have the recitations done, the slides, the notebook, as well as the video will be posted on the website. Again, we are stressing on this fact that even if you think you know everything, please attend the recitations. They can be extremely helpful. Coming to the grading scheme that is followed in the course, we will have 14 weekly quizzes. You will have quizzes on every Friday, the bottom two of which can be dropped. So each quiz will contribute to 2% of your grade, and you'll have 24% contribution from the quizzes. For assignments, you will have 5 assignments. I'm assuming that you have already received assignment 0, which is homework 0, which is preparatory. Although it contributes to only 1% of the grade, we highly recommend completing this assignment because it can make the others easy, and also it will also help you spend lesser time on issues that you might bump into in the next few assignments. The first homework will be about multi-layer perceptrons. You will basically be using MLPs in order to solve certain tasks. The second one will be CNNs, third is RNNs, and the fourth and the most interesting assignment is sequence-to-sequence modeling. Also be aware that all these assignments, at least homework 1, 2, and 3, will have 2 components. The first component will be that of Autolab, where you have a defined solution and you must upload your code to Autolab and you will be auto-graded there. And you will have another Kaggle problem in which you will have to compete with your fellow classmates in order to beat performances, and we will be releasing grade cutoffs, and you will basically be participating in an in-house Kaggle competition. And for students who are taking 11785, you will have a team project component. This is not valid for those taking 485. The team project will have 4 components, which is a proposal initially. Then we'll have a midterm report where you have to write about the findings that the findings before the midterm. You'll have a project presentation and a final report towards the end of the semester. The project is a great opportunity for you to do some really cool stuff with neural networks, and also probably publish if you get commendable results. About the weekly quizzes, most of the quizzes will have 10 or 12 multiple choice questions, and the quizzes will contain topics covered that particular week. So every week you will have 2 lectures, and most of the times the quizzes will contain content from these 2 lectures. Sometimes there might be some overflowing or underflowing, and we will let you know about that. Every week the quizzes are released on Friday, and it will be closed on the Saturday night. This may occasionally shift. Don't panic about that. Also about how much time you will be given for the quizzes. We will post all the information that you will require on Piazza. So like we said, there'll be a total of 14 quizzes, of which we will drop your bottom 2. This is just to account for any unavoidable circumstances that might creep in. And that's pretty much it about the quizzes. And once the very first quiz is out, we will post all the information that you will require on Piazza. About how to perform well in these quizzes, the slides often contain a lot more information than is presented in class. Remember that this is quite an intense course, and we are trying to teach you pretty much all the foundation that you require in order to get started with, say, a deep learning job, and therefore we must cover a lot of content in each lecture. And sometimes it might be possible that some content is not covered in the lecture, and sometimes this might also be done on purpose just to make sure that you go through the slides. Quizzes will contain questions from topics that are on the slides but are not presented in class. Professor Biksha might sometimes leave out slides on purpose, and this is an important cue for you because quizzes might contain these questions, or let's say will contain questions from topics that are on the slides but did not get covered in the lectures. And sometimes it might also happen the other way around, where we will include topics that were covered in class but are not on the slides. This is just to make sure that you attend these lectures, you understand completely the information that was provided to you in the lecture, as well as skim through the slides in order to understand completely. So that is about how to perform well in the quizzes. For the homeworks, like I was mentioning previously, there are two parts that come to all the homeworks, excluding the last one. You have auto-graded homeworks with deterministic solutions, which you must upload to AutoLab, and then you have the Kaggle problems, for which you must compete with your classmates on a leaderboard. We will post performance cutoffs for A, B, and C. So generally, when you have Kaggle competitions, you are marked on the basis of the accuracy or loss, etc., which you will be informed about. And depending on your points, we will have cutoffs for the A, B, and C grade. Generally, and this is. Mapped down to marks. A is generally 100, B is 80, C is 60, D is 40, and if you do not make a submission at all, you get 0. And if you do better than the A cutoff, then you will receive bonus points, which is 105 points. And the actual scores are linearly interpolated between grade cutoffs, and they will the marks that you will get for bonus will totally depend on the performance of the class, since we will linearly interpolate the marks that have been obtained above the A cutoff. And about the homework deadlines, you will have multiple deadlines. That is, you will have different deadlines for different components of the homework. You will have a separate deadline for the auto-graded component. Generally, the auto-graded AutoLab component has an earlier deadline than the Kaggle component. This is just to make sure that you first do the AutoLab part, because it's generally a little more simpler and less time consuming than the Kaggle component. And the Kaggle component will also have multiple deadlines, just to make sure that you at least try and attempt the assignment and make sure you complete it and learn. We have an initial submission deadline, and this is just to get you started with the assignment. Everybody has to make at least one submission before the initial submission deadline, and if you do not do so, all your subsequent scores will be multiplied by 0.9. So please make sure that you submit at least that is, you make at least one submission before the initial submission deadline. And for the full submission deadline, your final submission must occur before this deadline in order to be eligible for 100% marks. And even if you do not make it to the full submission deadline, you will have a drop dead deadline, until which you can keep making changes to your code, running your models, and submitting your files. So this is the last day until which you can make submissions. And for the homeworks, we have up to 7 total Slack days. These 7 days are given to you for the entire semester. You can you can distribute them as you like. And this does not apply to your initial submission, which means that everybody must make an initial submission regardless of the score you get during your initial submission. You at least must make one submission, and you can distribute them as you want across the homeworks. I would generally recommend keeping more slack dates towards the end and completing the first few homeworks without using slack days, because as you go forward, the assignments will get harder and you will probably slack off a bit. And also, it is important to note that you become ineligible for the A plus bonus if you use grace days for Kaggle. That is, say you performed better than the A cutoff and used one slack day, you will not be getting bonus points. You will only get the marks that are awarded for the A cutoff. That is, you will get 100. You can't get more than that if you use any slack days. And once you use up all your slack days, that is 7 slack days, all your late submissions will accrue a 10% penalty. And there will be no more submissions after the drop dead deadline, because that is when we release our solution, and there is no point making a submission. And the Kaggle leaderboards will stop showing updates after the full submission deadline, and we will open another late submission Kaggle that will enable you to submit after the full submission deadline has passed. And we will accept your submissions until the drop dead deadline. If this is too much of information for you to take, please look up the course webpage. There is a complete set of policies, and through these assignments, probably in the first 1 or 2 assignments, you will slowly pick up the logistics. And in terms of what you must expect from this course, how much preparation you must do for this course, let us tell you that this course is very implementation heavy. There is a lot of coding and experimenting. You will be working with very huge data sets. So you will no more be using toy data sets, because you will be participating in Kaggle competitions, and you will be doing modeling real time. And our language of choice is Python, and toolkit is PyTorch. You can definitely use other languages and toolkits, but I would personally recommend that you use PyTorch, because most of the TAs are well versed with PyTorch. They know the kind of issues that you can run into and the kind of structure of the code, etc. Therefore, you can get a lot more out of TAs if you use PyTorch. However, if you think you're better off with TensorFlow or any other toolkit, you're free to do so, but please be warned that the TAs will not be able to help you too much if you use other toolkits. And we hope that you have gone through Recitation 0 and you have gotten started with Homework 0. Although it does not contribute to a huge percentage of your grade, it is very important in order to be able to perform well in the forthcoming assignments. And additional logistics is we will be having discussions on Piazza. You can post any questions that might come up. I would also recommend to answer questions if you have solved a problem that someone's posting about, because you can totally get stuck on very trivial bugs and not be able to fix it. And when you find solutions on Piazza because someone else has already done it, it's extremely helpful. So please post questions as well as answers on Piazza if you have solved issues. And since most of these Kaggle competitions require GPU resources, each of you will be getting Amazon tokens. Initially, we will give you a $50 token, and we can extend that up to $150 as your assignments progress. So the total budget for this entire course will be $150. So we would definitely recommend using these resources with care and not overusing them. And since we have had many students take this course before, we know that $150 is definitely sufficient for this course. And just to end off, let us tell you again that this course is a lot of work, and which is sort of expected because this is a course that basically gives you all the foundations required for deep learning. And I personally benefited hugely from this course, and it helped me during my internship search. It helped me during my internship, and like I told you, it's one of the most valued skills, and nothing worth having comes easy. This course is a lot of work. Just in case you don't believe me, this course is a lot of work. You have to probably spend a few sleepless nights tuning your hyperparameters. You make mistakes, you must learn from them. You must become a neural network where you learn from your own mistakes. And just in case you're still in doubt, this course is a lot of work, and it is not meant for chickens. If you think you can breeze through this course, do things last minute, and probably pick up some hacks, that is definitely not going to be possible. This course requires you to dedicate a lot of time on it, and the amount of knowledge that you gain in terms of both the practical skills as well as conceptual skills is huge. This course basically turned my life around, and I hope it's similar for you too. But yes, there will be days when you probably will have to work a lot. And another important thing is that we believe in a mastery based evaluation. In the previous slides, we also mentioned about how we have a little bit of lax deadlines just to make sure that you learn and understand, and you're not under the pressure to just complete the homework, but you also have in mind that some learning is happening. The quizzes are also extremely important in order to test your understanding of the topics covered in the lectures, and the homeworks give you practical knowledge, and they teach you to implement complex networks and optimize them to a high degree. In most of the Kaggle competitions, you must optimize your parameters in order to beat the A cutoff, and perform better than the others. And the target of this course is that anyone who gets an A in this course is technically ready for a deep learning job. And I think most of the students who have taken the course in the previous iterations will definitely agree with this. Uh, Finally, to conclude, please go through the videos for recitation 0 and also complete homework 0. It is very important in order for you to gain comfort with the coding that is required in the following homeworks. You might also feel that homework 1 part 1 has many components and it's a little intense, but this will definitely help you. And also start early because you might get stuck with many errors, and since you have never for students who have not, coded deep learning architectures before, it might be difficult for them to pick up initially. And also, even if you feel that the first homework is pretty dense, let us warn you that this is the most easy homework of them all. As you go, as you strive forward in this course, the homeworks will get more and more difficult, but the amount of satisfaction that you get after solving each of these homeworks will also increase. I assure you of that. And if you have any other questions about this lecture or anything to do with the logistics, anything that you feel hasn't been covered in this lecture, please post on Piazza.